Welcome to Graphs of Absolute Value Functions. Let's get started. What we want to answer by the end of the video is what is absolute value and how do you graph an absolute value function. So absolute value is the distance from zero on a number line. That's why it's always a positive answer. Okay, these little lines here represent the absolute value. So this would be, what's the absolute value of 3? And our answer would be 3. And we would also say, what's the absolute value of -3? That would also be 3 because we're talking about the distance from 0. So absolute value can't be negative, right? If you look at that number line, see 3 is always 3 spaces away from 0, and -3 is also 3 spaces away from 0, which is why the absolute value of -3 is +3. So this is the absolute value parent function, y equals or f of x equals the absolute value of x. It's going to form this v. It looks like a v. It's like two lines that come together to intersect at this point, and this point right here is called your vertex. And for the parent function, it's 0, 0. For all other functions, all other absolute value functions that we graph, it'll be h and k. So the transformation equation that I need you to remember is y equals a times the absolute value of x minus h plus k. And I'll explain what these stand for. But you can see whatever your h and your k is, that's your vertex, h and k. So this a right here, that is going to tell us a few things. It's going to tell us how wide or narrow that V is, the vertical stretch or vertical compression. So if our A is greater than 1, then we're going to have a vertical stretch. And what that means is our graph, that V is going to get really narrow. If our A is in between 0 and 1, that means it's like 0.25 or 3/4, something in between 0 and 1. Then we're going to have a vertical shrink or vertical compression, which means it's going to be really wide. So if we're having a stretch, that would be a stretch because it got more narrow. A compression would have gotten wider like that, like the black line. So I'll put this here if you need to go back and look at it. And then the final thing about the A is if it's negative, if it's a negative number, okay, then it's going to reflect over the x-axis, which means it will flip upside down. So it will look like an upside down V. That's what our A tells us. So our A tells us a lot of things we'll have to remember. The H tells us our horizontal shift, or how our vertex is going to move left or right. And the thing about the H is you always need to change the sign of your H. And we'll talk about that in a little bit. Okay, so the next thing we want to look at is the K, and our K is going to tell me my vertical shift. So it tells me how it moves up or down on that y-axis. And for K, we're going to keep the sign. Keep sign of the K. And again, that vertex is going to come from our H and our K. That's going to be the starting point, that vertex part of our absolute value graph. So we're going to do an example here. So remember from what we just wrote down, and I'm going to put it here so you can see, but we had y equals a times the absolute value of x minus h plus k, right? So that means my k is 3. We keep the sign of our k, so my k is 3. And my h, right here, it looks like it's -2. We change the sign of the h, so my h is +2. Okay. And then this A right here is in between 0 and 1. So we're going to have a vertical compression or a shrink, or it's going to get wider. Okay. So that's what my A tells me. This is going to be wider than the parent function. It's going to move to the right 2. H is my horizontal shift, so that vertex is moving 2 to the right, and then it's moving up 3 because K is my vertical shift. So up 3 to the right 2, and it's getting wider. So let's graph that from here. Remember that the vertex was your HK. So this vertex is positive 2, 3. So from 0, 0, it did move to the right 2 and up 3. So that's where I plot my new point, my vertex. Remember, it's going to make this V shape. Okay, it didn't turn upside down because it's not negative, but it did get wider. And so the way we graph that from here is just like you would graph a line, rise over run. So we want to go up 1 over 2. Up 1 over 2. And because it's the V, because it's two lines together, we're going to do the same thing the other way. Up 1 over 2, up 1 over 2. So that's the absolute value graph. So remember, the parent function was like this, the black line. So it did move to the right 2 and up 3, and it is wider than that original parent function. All right, so we're going to do another example because I know that can get a little confusing. So again, I'm just going to write that ax minus h plus k. All right, so this graph, it's negative. Our a is negative, which means it's going to be upside down. Okay, it's going to reflect over the x-axis. That's the first thing we should see just by looking at this equation. The 2, so a is greater than 1. That tells me that it's going to stretch, or you can say it's going to be narrow. It'll be skinnier than the original parent function. This 3 right here, that's my h. You always change the sign of your h. So my h is negative 3. And then this is my k. So you keep the sign of your k, so my k is negative 1. So this is what we should be able to tell right away just by looking at the equation. And we'll have practice on that. But you need to remember this. Now, our vertex is my hk, remember? So my vertex is negative 3, negative 1. Again, that means from 0, 0, it's moving left 3, down 1. So I'm going to left 3, 1, 2, 3, and down 1 is right here. So that's my vertex. So my lines are going to go out like this, upside down because of the negative. Now that you're at your vertex, we just need to move with the A. Just like we do with a line, rise over 1, run. So my A is 2, or 2 over 1. The negative only tells me that it reflects. It doesn't have anything else to do with the stretching or the slope. So 2 over 1. So we're going down 2 over 1. Down 2 over 1. We know we're going down because a negative told us it reflected. And then you go the other way. Down 2 over 1. So there's the absolute value. It is a little more narrow than the parent. And from the parent function, it did do what our h and k told us. It moved left 3, down 1. And it got more narrow, and it was reflected because the original goes up. All right, so don't forget to write your summary and your questions. Go back through the video if you're getting confused. Remember, we want to be able to say what absolute value is, right? The distance from the number line, the distance on a number line from 0, and you also want to be able to explain how to graph it. So knowing that transformation equation is really important. Okay, what does A mean? What does H mean? What does K mean? So you should know that. You don't have to be perfect at it, but make sure you understand it before you come into class. Watch that video again if you need to. That's it for now. Thanks. Bye.